Are there any more? Would you pass me on this?
Yeah.
Oh, is that the only one left? Okay, guys, let's go through some of these together on the work that you're doing right now. I just wanted to go through number 1 and 2 with you, and I'll let you guys do 3 and 4. Okay? So only because I saw some people struggling or did not do 1 through 8 on colligative property, so you may be a little rusty with that because you didn't practice it. So on the table, you guys tell me from the solute, tell me the number of particles. And if you've written on this, if you can erase it, that's great. If you can't, then I'll make more copies. Sorry, I meant to tell you don't write on the colligative property worksheet 1 through 4. So the table, Caroline and Kathleen, tell me sucrose, number of particles. Right, 1. Why? Yeah, anything that's covalent is only going to be a molecule. It doesn't break into ions because it doesn't have ions in it. Gwen and Alyssa, sodium sulfate. How many particles does sodium sulfate break into? How do you know that? And we don't break sulfate up because we're not homewreckers. We're not homewreckers. We leave sulfate as a happy family. So there's 2 sodium ions and there's 1 sulfate ion. So I is equal to 3. Yeah? Okay, so that's 3 particles. Magnesium chloride, Jalen's group. How many particles does magnesium chloride break into?
3.
Why?
Because it's ion.
So what's it?
Magnesium.
1 magnesium 2 plus and
1 chloride and 1 minus.
but how many of them? 2 of them, right? So there's 2 chloride ions, so 1 plus 2 is I of 3. So you're uncrisscrossing, but you're still saying there's 2 of these and there's 1 of these. Methanol, Natalie and Audrey. Why 1?
Because it's non-metal.
Right, so this is a covalent structure, non-metal, 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 non-metal. You say it's covalent. I know some of us are like, oh, that's OH on the end. That's an alcohol group, not a hydroxide. It's not an ion, so it's I of 1. Okay, so are we okay with determining the Van 't Hoff factor? The Van 't Hoff factor is the name of I. Whenever I separate them, it's the numbers in front of them, which are the subscripts. So that's why it's like 1, there's 2 sodium, so there's 2 right there, and there's 1 sulfate, so 2 plus 1 is 3. Let me give you a hard one. Here we go. Aluminum acetate. Write out the formula for it on your paper. Aluminum acetate. We're like, throwback to nomenclature. Like, oh my gosh, what's acetate? Let's go Zach and Ty. What's aluminum acetate? And then tell me the I factor. Tell me aluminum acetate first.
See, this may be wrong, but I said Al and then parentheses H3 3 per subscript.
Okay, hold on. Ty, tell me what the I factor is for that. Or the Van 't Hoff factor, the number of ions. Right. How'd you get 4? Tell me your process. Right, there's 1 aluminum ion, and there's how many acetates? 3 acetates, C2H3O2, 1 minus charge, so there's 1 of these plus 3 of these, that's 4. Okay, so according to, now this is kind of theory behind colligative properties. Why in the world are we figuring out the number of particles that these things break up into in solvent form? Because that's what happens when it goes into solution, but why does it matter? Because the more particles do what to the solution? Yeah, but like what properties, so what are the 3 colligative properties? Ready? Okay. And vapor pressure lowered, okay? So my thought is that if I know that something has a lot of particles in it, it's going to make a more significant change of that property. So of the couple that we've compared, aluminum acetate, sodium sulfate, methanol, magnesium chloride, and whatever this thing was, sucrose, which of those is going to have the greatest impact on freezing point depression? Who's going to cause the greatest delta T? Why?
Because the most particles.
Right. So the number of particles are correlated with the magnitude of change. So if you have more particles, you have a greater depression of temperature or the elevation of boiling point or vapor pressure lowering. So it's just based off number of particles. That's what we have to know the I factor. The solvent does matter, but it's really about the number of particles it breaks into. So which of these would they use on the roads to make us come to school so that for the roads don't freeze? Aluminum acetate, because they're like, hey, we're going to decrease the freezing point of this water because we really got to come and get an education. They're missing chemistry class, people. She's on YouTube, and she will send it to you if we have snow, but we don't have snow. Okay, so let's look at question 2. When 5 grams of calcium chloride dissolves in 50 grams of water, what is the boiling point of the solution? The kV of water is blah, blah, blah. Tell me your formula. Tell me your process. I'll give you guys a minute to discuss that with your team if you need to. You may have already discussed it. Yeah, go for it, Kelly.
The formula is K-I-N.
So, delta
Delta
T.
T equals.
And people in the back, if you guys can't focus, then scooch closer. Okay, so the formula is delta T is equal to KIM. That's the generic formula for everything, boiling point and freezing point. Do we know this? Do we know the T? No, that's what we're looking for. It says, what's the boiling point of the solution? But what is it really looking for? It's looking for the change in temperature, and then we're going to adjust the boiling point, the normal boiling point, by the temperature change we determine. Jalen, what's the K for this one? Jalen's group. What's the K for this one, number 2? What is it? And this is in reference to calcium chloride or water? Right, because the K is always about the solvent. So this is the degrees C per molality, the K for water. How do you get the I, Hannah, B?
You see how many particles there are,
Okay, ready when you are?
which is 3.
Right, so calcium chloride breaks into 1 calcium and 2 chlorine, so that's 3 total. And how do you get the M, Tydasia, and Samara? Okay, so I'm going to go ahead and do kilograms of water. Can you look at number 2 and tell me what kilograms of water is? Right, so we took 50 grams, bounced the decimal back 3 spaces, and you got 0.05 kilograms of water. And then tell me what I would be doing on top in order to get the moles. Samara. So 5 grams of calcium chloride. Anybody got the molar mass for me yet? Okay, so 1 mole on top and 110.98. I'm just doing all my math in one big step. I didn't calculate anything yet, really, okay? So we take our KFP, our BP, times by the I factor, times by the moles over kilograms of the calcium chloride, and I'll give you guys a chance. If you guys already got it? 1.3824. That's our delta T. And this is boiling point elevation, so that means the boiling point is increasing. So we're going to take our normal boiling point of water, which is 100, and we're going to add it to the delta T to that. So then what's the new boiling point? 101.3824 degrees C. So I'm going to go with 101.4 degrees C. 101.4 degrees C. So that's going to increase the boiling point of our water. And where would that be useful? Cooking food, right? So if you want to not have your water boil over, and you still want to keep the water in the pot, you want it to boil at a higher temperature. Your stoves don't, I mean, they get hot, but they may not get 101.3 hot. So you put salt in your water, spaghetti doesn't boil over. Bada bing, bada boom, we are chefs. Master chefs. We should have a master chef challenge based off chemistry skills. Oh my gosh. I'm gonna figure this out. Okay, so work with your partners on 3 and 4, and then I'll go over homework questions as needed. Maybe. Does anybody have 2 by chance? I need like 25 copies. So, if you're working with a partner, you should just have 1. Do you have still somebody? And I need to be as working partners so that I could not make as many copies, and I'm gonna make more. I've already been yelled at for copy counts this year. Oh, good. Okay, if you're done with 3 and 4, then go ahead and wait on us, but go ahead and start working on your unit review. If you're done with 3 and 4, start working on your unit review while you wait on us, because I want to check these. Hmm? So the benzene is the smaller one, so it's the salt. It's going to be the salt. Whenever you convert it, it'll be the salt. Because the bigger amount is the salt you, I'm sorry, the smaller the amount is the salt you, the bigger amount is the salt. And I need to tell you the boiling point of naphthalene. No, that's the KB, the actual boiling point. The normal boiling point, right? No, like water's normal boiling point is 100. This one's gonna be different, and I don't have it in front of me. Tell me where we are in 3. I'll keep calling on you, so don't shout out just yet. 3. Tell me your formula. Rebecca's group. You and Emma. Tell me what you plugged in.
5.65.
Hmm?
I is 1.
Okay. Why is I1 Jake? Benzene is covalent. And then, what did you guys do next, Alyssa?
I took
6 grams and did what?
I turned my 1 mole over.
And what's the molar mass? Okay, so that got us moles, right? And I know we can do that calculation. What's the solvent kilograms Hayden? Mm-hmm. Okay, and are you guys cool with me? I'm putting all the work just in one big blob. Do you understand what I'm doing? Okay. So basically, this is moles when you cancel out your grams, and this is kilograms of water. This is moles of benzene, and this is not kilograms of water. This is kilograms of naphthalene or whatever. And so, what'd you guys get, Sally, for your delta T? Say again. 12.4 degrees C. Does everybody concur? Okay. So, Jack, what's the new boiling point of naphthalene?
230.4.
How did you know the original boiling point? It was on the board, right? So it's not 100, it's just whatever the boiling point of naphthalene is. It's 218. That's something you just Google. Only boiling point that's 100 is water. So this plus the original of 218, and you got 230.4. Whew, that's a high boiling point. Okay, and then the last one, let's wrap this one up together. Some of us have already accomplished it, but I feel good that we know what colligative properties are, right? All right, so Miss E's feet are aching by the end of the long day. At home, she dissolves 26 grams of Epsom salt in 1.5 kilograms of water because I like to use my kilograms at home. I have a scale. I don't. That would be kind of crazy. I do have a scale, but it measures in pounds. Can I change it to grams? I don't know. Okay, so what's the freezing point of the solution? Zach, tell me how to get started. Number 4.
Well, you already have K, and then for I, let's see.
So 1.86 degrees C per mol. What's our I here?
I would be 2, I believe. You don't break up sulfate.
Right, so magnesium is 1 ion, sulfate is the other ion. That's 2 ions together.
And for molal, you have to convert 26 grams to moles.
Okay, so 1 mole of magnesium sulfate is 24 plus 32 is 56 plus 64. What did you say? 64 plus 36. It's like 110? 120?
I got 120.38.
Thank you. 120.38. Okay, so there's how we got the moles divided by 1.5 kilograms of agua. And everybody tell me the temperature change. So what is it? 1 point. 1, 2. Okay, so that's our delta T, and then tell me how you found the new freezing point of water. Sorry. Right, well, so it's depression, right? So freezing point depression means to subtract. So you subtract your change. So the new freezing point is negative 1.12 degrees C. New freezing point, NFP. There you go. All right, so who likes colligative properties? Okay, this it's not bad. There's one formula. You got to know what each of the variables mean. But once you kind of figure out your flow, it's kind of repetitive. So do me a favor. If you are good with PS 1516 and you're going to turn it into me because you don't have any questions, then go sit at the lab stations in the back. If you have questions on PS 1516 or 1 through 8 colligative properties, then come sit in the front. After you, if you are going to sit in the back, you guys are going to go ahead and start reading. So listen before you move. You're going to start reading an article for me, Pick Your Poison, Making Ice Cream, or Salting the Roads. Make sure that you, we kind of have some equal representation here, so not everybody pick ice cream. And I just want you to write down some facts you learned, and I have some that's brown paper. So if you're in the back, you're starting to read articles, and you're writing those facts. And if you're in the front, you're going to ask me those. All right, I'll give you 30 seconds to make your choice here. Yes, if you're done, come in, Sabah. And if you're not, then... Fix your, what do you mean number 6? On the PS?
Yeah, it was like, which format?
So yeah, do not turn it in until it's complete. You got me? Okay. If they're complete, you're good? Yes. Good. Yes. Yeah. I just believe people. I like trust you guys a lot.
Yeah, I didn't get one.
Ugh, why didn't you guys say that? Now I'm just like totally
What
misconstrued.
you mean?
Well, I had to do it like 3 times to make sure.
You're hating on my calculation?
You got 0.53.
Yeah, that's like...
Ty. Embarrasses me, man.
Emma?
Embarrasses me. I got 0.53. They 0.5.
That's only 0.4 off.
356 degrees C. Lies, guys. The new freezing point is negative 0.5356.
Lies.
I have people that take care of me.
Good job, Ty.
Thanks.
Thanks.
It's just because Ty told me the wrong number. I can't help it.
I
So
calculated
lies
it
to me.
correctly.
This one, I have this one decimal point. They're all the same numbers.
Well, in that case, then my
Like it's
homework
supposed to be
is
8.49. That number. And I did it like 3 times.
What is this? Give me a second. I saw that note there, and I'll look at it later. Okay, if you're in the back, you are reading and writing down some facts about what you're reading. If you're in the front, ask away. I'm going to start with problem sets 1516. Problem set 1516. Go for it, Ty.
Number 1.
All right, if you're in the back, please be kind of quiet, okay? Okay, so this right here is a solubility curve question more than anything. But instead of actually putting the solubility curve on here, you guys had one on your paper. So I told you that KCl at this temperature is saturation is 0.456 moles per 100 grams. So then, what mass of KCl will there be able to be in a 500 gram sample of water? There should be, if you have 100 grams in here, that's 5 times greater. So you should have 5 times the number of moles that are allowed to dissolve in 500 grams of water. Does that make sense?
Yeah.
And then you had to convert that to grams from moles to grams. So I'm going to keep that as a short explanation. Next question, that answer number 1 for you as well. So if gosh, how's it already almost 11 o'clock? So if you had 0.456 moles in 100 milliliters of water, that's going to be a 5 times greater than if it's dissolved in 500 milliliters of water. So that's what that's like 2.28. Thank you. And then you'll convert that KCl moles to grams. Okay. Another question. 1 through 11 people. Ask away. 11? Oh yeah, I knew number 11 was going to be one of those. So, and I think it's because you just don't know that you just would have to Google the boiling point benzene. So, is it 11A or B?
B.
I'll kind of do the setup for both just in case, okay? I'm going to start with B. So, if you have 40 grams of carbon tetrachloride, you can take, what's the formula for carbon tetrachloride? CCl4. Okay, and then you had to, oh, there's a marker. It's here. I'm just going to pull this over here so I have some space to write. So 40 grams of KCl or of CCl4, 1 mole of that. So this is going to be the solute, while benzene is the solvent, because the lesser one is the solute, the greater one is the solvent. So the K is going to be in reference to solvent, which is benzene. And what's the KBP for benzene? 5.12. It was in the book. You guys, do you remember seeing that in the chart? It's on like 498 in the book or something like that. So 5.12 degrees C per molal. Huh? That one's for water. Water's 0.512. That's molal. Okay, and then this needs to be converted to grams. So 140, 140, 152. What's the molar mass of carbon tetrachloride? Did anybody get this on number 11?
Oh wait, I think I did.
153.81 grams. I'm just estimating in my head. So this would give us moles. And so what is that in moles? 40 divided by 153.8. 2601 moles. Okay. And that's solute. All right. So then determine the new boiling point. We're going to use our same general format of delta T is equal to KIM. Delta T is our question. Our K is in reference to benzene, the solvent, 5.12 degrees C per molal. I factor is based off the solute, which is what for carbon tetrachloride? It's, do you see metals or non-metals here? All non-metals. So it's chlorine and carbon are both on the upper right, so that's a covalent structure. So I have 1, right? And so then our molality is just going to be our math right here. So 0.2601 moles divided by this in kilograms, so 0.450 kilograms. And then plug that in. That's going to be our delta T. And then we'll take the freezing point of benzene. Freezing point of benzene. .5 degrees Celsius is benzene's freezing point. We're looking for boiling point. Thank you. I generally do freezing point. I love the freezing point for some reason. 80.1. 80.1. Okay, so then our new freezing point will be elevated from 80.1. So our normal boiling point is 80.1 degrees C. What's the delta T here, guys? Anybody got 11B? Or you can calculate? 2 what?
0.95.
Okay, I'm believing you. You know what that does sometimes. Okay, so double checking. So we'll take our elevation, our delta, our elevated temperature change, and add it to our original, which is something you just had to look up. So that's 83.059. Yeah. So about 83.1 degrees Celsius is our new boiling point of benzene. So that one was just harder because you probably didn't realize you needed to look up the boiling point benzene. Do I need to go over A as well? 11A right now? We'll just kind of just basically set it up. It's going to be delta T is equal to water's boiling point elevation constant, 0.512. Is that water's boiling point elevation constant? Thank you. I always get benzene and that one mixed up because they're so similar. Times the calcium chloride. I factor is what, guys? We've already done calcium chloride once today. 3 calcium and 2 chlorines. So that's a 3, and then the molality is 0.150, and that's already given to us as M. No need to calculate it, and then we'll just calculate from there. Okay, any more on problem 17 and 16? 7, 8, and 9. And I might do a couple just orally here. So 7, these equations you write for dissociation is just like a BCE, where you take your salt and you draw an arrow and you show me how it splits up into the 2 ions or multiple ions that it forms. It's very simple. So let me do calcium phosphate for you here. Over here. So calcium phosphate, Ca3PO4. When dissolved in water, you can put water above the arrow to indicate that it's aiding the process of dissociation. It breaks into 3 calcium ions. You put 3 calcium, 2 plus ions, so that's the charge of calcium, and 2 phosphate ions. So plus 2 phosphate ions. So it's basically what we've been kind of showing in our method of figuring out what the I factor is, but it's just more formal now. So we're like, we make 3 calciums and 2 phosphates. What's the I factor here? What's the Van Tau factor? 5, because it's 3 plus 2. So that's how you write out the dissociations of each of these salts here, here, and here. Yeah. 8. How many grams of sodium chloride must be dissolved in 750 mils of water to make a 0.5 molal solution? Okay. All right, people in the back, how you doing? You're going to be hopefully sharing it with us soon, because we're all not going to get a chance to read it. Okay. 8. How many grams of sodium chloride must be dissolved in 750 milliliters of water to make a 0.50 molar solution? Do you guys remember the magical equation if you have molality and kilograms? Because isn't this is just water, right? Can't that milliliter immediately be changed to grams? Because 1 milliliter of water is equal to 1 gram of water. And then, how many kilograms is this? 0.750 kilograms. Okay, so I'm actually going to circle that one instead. So if you have 0.750 kilograms and you have molality, what do you do with them when they are given together? You multiply them to cancel what? The kilograms, right? So 0.750 kilograms is what, that manipulation was not difficult, it's just you had to kind of see it at first, times 0.50 molal or mole of NaCl over 1 kilogram of solution or solvent. That's going to be our molality broken into the 2 units that it actually consists of. So kilograms and kilograms cancel, and that's 0.15. What is it? 0.375, way off. Okay. Moles of NaCl, and then what do you have to do from there to find the grams of NaCl? The molar mass, right? So we'll take our this times the 1 mole of sodium chloride and its molar mass of 58.44 grams, which you just had to add up from periodic table. And that mole here and mole here will cancel to give us grams. And then if you guys need help on number 9, I'll do that one later. How about anything on 1 through 8? Yeah. Number 3. Do you mind reading that to me right now?
How much will the freezing point on the water benzene be worth if the solute is dissolved in a sample producing a concentration of 0.25?
0.25 molal. How much will the freezing point of a pure benzene solution be depressed if you have a 0.25 malal of what? Okay, that might be a problem. Let me grab my sheet of plastic. Does it say non-electrolyte or non-volatile solute?
No, it just says solute.
Okay, if it says solute and it doesn't tell you it's ionic, I want you guys to assume it's covalent. Okay, so that's going to tell us with the I factors, it's 1, and that was just my mistake, because you guys did that at the end of class Friday, and I didn't get to talk about all these in depth. So the I factor is assumed to be covalent, so it's I of 1, so then delta T is equal to KIM, or K for benzene is this is boiling point, is 5.12. Oh, the freezing point was. No, this is boiling point, yeah, that's right. And then times by 1 times by 0.25. Yeah, that was an assumption. It doesn't tell you the nature of the solute, assume it's covalent. Because otherwise you wouldn't know what the number of ions it would be anyhow. Okay, 1 through 8, guys, more? 8. Okay, and if you've not done 1 through 8, then you should be doing 1 through 8 right now. So some of you guys might be reading, I forgot to tell you that. If you've not done 1 through 8, then jump on it. So 8 told us, can you read number 8 to me, Caroline?
Yeah. If 46.0 grams of magnesium bromide is dissolved in what is the boiling point elevation and what is the
Okay. Well, you're not the only one, because there are other people who need help on this one. So if you have the solute given to you of magnesium bromide, go ahead and tell me the I factor. 3, because you have 1 magnesium and 2 bromines to make 3 total. This can be converted immediately to 500 grams, because you know that for molality you need grams and or kilograms. So then this is equal to 0.500 kilograms, and you move the decimal over. So that's going to be, this needs to be changed as well to what? If that's our solute. Moles, so 46 grams of magnesium bromide. 185, 184. Oh, hold on, I have it right in front of me. 184.11 grams of magnesium bromide is its molar mass, so that's 0.249 moles of magnesium bromide. So this is our moles, there's our kilograms of water, and what else do we need? Oh, there's our I factor. What else do we need to find the boiling point elevation change? K of what? Magnesium bromide or water? Which one? Which one? Water, because it's a solvent. K is the solvent constant. So that's for water 0.512 degrees C per mole. And that's just the value I would always give you. But on this question, you guys have your books available to you. So then all this lovely data will allow us to plug into KIM. So 0.512 degrees C per mole. I have 3 for magnesium bromide. And molality is 0.249 moles divided by the solvent kilograms, so 0.500 kilograms, to give us our basic setup. Yeah. Oh yeah, please, yeah, go ahead. Okay, so the delta T is 0.768 is what I got, so I'm just going with it. That's our delta T is our change, so then what's the new boiling point of water, Suzanne?
100.
Right, so new boiling point is 100.768, because you're taking the change, adding it to the original boiling point of 100, so it's just a hair above 100. Okay, if you need individual help on any of these other ones, before you turn your PS and 1 through 8 in, please let me know. but I want to make sure that you guys have time. If you're working on an article, are you guys close to done? Okay, I'm gonna have you guys share just like 3 or 4 minutes, if that's okay. And then if you're working on your review, that's great. If you're done, and then I'm gonna hopefully pass back Gaz's husband just a second. Questions first. If you're waiting on me, please work on something else. No, the Molly and Lee went through so is it salt versus sugar? Or something else? Oh, so sugar has a high properties to do with the gold.
Well, no, not the actual question.
Hold on, I have a question right here. Oh, equal number of moles of calcium chloride and sodium nitrate dissolved in equal volumes of water.
So it's separate containers?
Yeah.
Okay.
So it's like, it's basically saying does calcium chloride or sodium nitrate cause the freezing point to change more, boiling point change more, and vapor pressure change more? So was it really mattering? What really matters here?
Boiling point and vapor pressure
They're the same direction. But when you're comparing calcium chloride and sodium nitrate, what really matters? What's the main difference between the two?
So did you want us to list which one had a bigger difference for A, B, and C?
No, which one is lower for A, B, and C individually. So here's what I want you to do. I want you to go through and say calcium chloride has an I factor of what? Sodium nitrate. Sodium. Nitrate is its own entity. So this is sodium and nitrate, right? So that's I factor. Don't be a home wrecker. So the I factor is greater here, right? So that's going to cause the delta T to be greater for all of these cases, just because they have the same number of moles, the same volume. And it's all talking about water staircases and all. The only difference is the I factor. But I factor causes freezing point to depress more, right? So comparatively, between these two, who's going to have the lower freezing point? Calcium chloride, yeah, because it just has a greater I factor. But these two go up, right? So their boiling point elevation and freezing, vapor pressure lowering is something else. But the boiling point goes up, so this one's going to have a greater delta T for the boiling point, which means it's going to have a higher one.
Because I didn't do nitrate as well. So I literally put that one, and then I put sodium nitrate for
Well, yeah, but I'm glad that you understand this and we'll just be lucky answer. You know what I'm saying?
So that's like it's weird.
And I want to go over yes. Yes.
So where is my favorite
This is a non-electrolytic solution because it doesn't resolve salts. All right, my article people, give me a thumbs up if you're good to share. Share what you can. Thumbs up to share what you can. Okay, come on up here. Let's go. If you are Salty Road, stand on this side, and if you are ice cream, stand on that side. Let's talk quickly about this because this is what we're talking about more tomorrow, okay? Everybody who's sitting and listening, you're writing down some facts that they say. I want 3 facts from what they say. Write it down for me because you did not read the articles.
Miss Emma, are you using that rubber band?
No, you can't. Yes. All right, salty Roads on that side, ice cream on this side.
So,
Yeah, it
Okay, and everybody here, up here in the front, is listening. We're going to go with Salty Roads first. How many points are you writing down?
3.
3, and write it on the warm-up that you've been kind of writing down your Socrative work on. So you may have had 1 sheet of paper where you write down your Socrative work, your colligative property, 1 through 4 that we just did together, because I'll take that one up for participation in class today, okay? So you may not have all the work on it, but at least it shows that you're participating. So, Salty Roads, I want everybody to say 1 or 2 things about what you've read, what your article's about.
One of the new methods they're using for salting roads is they're putting the anti-ice mixtures into the concrete when they pave it. So it's kind of like part of the road. And then the salt, besides actually melting the ice, can cause corrosion on the cars, bridges, and highways that it's put on. So it's not all good stuff.
Right, so it's great for letting us come to school, but then our cars eventually will erode and we can't come to school. Gotcha, okay.
Magnesium chloride and calcium chloride are more effective than sodium chloride because they dissociate into 3 ions compared to 2. And about 15 million tons of salt is used in the U.S. each year.
Okay,
For this
so
purpose?
What?
For this purpose?
Yes.
Holy cow.
okay, so a salt inhibits the formation of the crystal lattice of an ice crystal. So when ice freezes, the ions of the solute are basically ejected, and so you end up with a progressively more concentrated solution where you have the water that's still liquid. So the ice is pure water, and the concentration of the liquid water, the salt in it, increases, resulting in you have to the freezing point is increasingly decreasing, so you have to keep lowering the temperature to make that water freeze.
So
The other thing,
so like so once stuff does start to freeze, the rest of that stuff's not going to freeze until it gets really cold.
I didn't word that very well.
No, I'm
Yeah,
just
yeah.
rephrasing it. It's good.
And also, some bridges actually have sensors on them, so they know when it's about to hit the freezing point of water, and they'll actually start spraying themselves with a de-icing solution to prevent the crews from having to go out there and do it manually.
Robots are going to run the world, guys.
Salt plays a crucial role in preventing snow and ice from bonding to the pavement. And they're starting to find new ways instead of using salt, and they want to start mixing magnesium chloride with sugar.
Ooh. Yeah, because a lot of times high salt environments are going to start to kill our plants on the side of the road and certain animals. So they have to use salt because it creates a lot of ions, but it's also somewhat detrimental to the environment, especially with the runoff after the stuff starts to melt. There's a bunch of salt in our fields, and some like bacteria are halotolerant, which means they love salt. So there might be an increase in bacterial populations, which might send, just somewhat disrupt the food web, right? So that it's a great for the quick solution, but not long-term solution. Cool. Thank you, Jean. Make sure I get your notes, and I want to give you guys some extra credit for that because I appreciate you guys doing that for the team. So make sure I get your notes in the box. You guys can sit down. That's good. Next group. They kind of went through the whole article kind of, I think, sequentially. So if you guys can try, that'd be great. This one's ice cream, right?
So, the ingredients of ice cream is cream, milk, sugar, air, and flavoring. And the cream doesn't separate like oil and water because it's each like droplet of butter fat to make the cream is surrounded by a protein membrane that attracts water molecules, so it mixes
Instead of separating. Okay.
For those of us who took notes on this, do we take notes?
Yes.
Just because you're sitting down now, I want you to listen. Go ahead, next method.
Okay, in order to make the oil and water mix, an emulsifier must be added, and a natural emulsifier is then found in the liquid
Glycid.
Emulsifier
Yeah, speak louder so these deaf people over here can hear you. So can you say what you just said again?
To make the oil and water mix, an emulsifier must be added, and one natural emulsifier that is found in egg yolk is
Lectin. Can you see the word? Where's that? Oh, just lectin. Just lectin. 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 I thought you said lectin. Sorry. All right, next.
To make the ice cream like solid rather than a liquid, you have to stir it really fast to fluff it up with air. If the ice cream melts, even like it's just a little liquid, and then refreezes, the ice crystals will grow larger and they invade the air.
And we've all had like that ice cream that's in the freezer too long. What's it have on it? Freezer burn. Freezer burn is simply huge ice crystals that are embedded in, like maybe on the top where the most air can have access to the top of the ice cream, and then you get a lot of vapor that have maybe is recrystallized. So they're larger crystals, so you can actually taste them. They're watery.
A liquid that has been churned, chilled, is like solid, but a liquid with a lot of air bubbles.
Keep going. It's not happening. You said that has, you said colloid and what else? Oh. Anything else you can add?
The most popular flavor of ice cream is vanilla.
And that's what we're making tomorrow. The most popular flavor is just plain old vanilla. Okay, so.
You can't make topping.
Oh, but you can make chocolate by putting syrup in it. Okay? So, right now, you guys go sit that back down. You're good. Thank you. Make sure I get your notes before you leave. Okay? We have about 10 minutes left in class. I want you guys right now to work on your unit review. Instead, I was going to do some notes, but I'll do the notes really quickly tomorrow. So, here you go, guys. Who has started the unit review? All right, what number do I need to go down to? I'm leave it there.
I didn't take notes when I was
Give me something because I won't remember that. All right, guys, please do not waste your time. You have 15 minutes, 12 minutes right now.
Yeah.
I want, before you leave, I'm going to wait. Before you leave, make sure you at PS 15, 16 in the box, 130 in the box, the participation for today in the box, whatever happened on some paper. Just call it participation today. That's cool. I'll understand what it is. And work on your unit review. Do not waste time. And if you want, I will make a list up here on the board if you're going to bring what toppings. We don't have everything, or you guys just make a note on your phone. Bring an amazing topping for ice cream. Yeah.
What was it? Colloid?
A colloid is a mixture of, in this case, it was cream and fat. It's something that was oil-based, which is the fat and milk fat, and water-based, which is kind of like the milk and vanilla, and it pulls it together to make a colloid. I'm trying to think of what they said in the article. I have to make this. My room will be during 8. My room will be during 8. I'll be in that. Okay, great. Yeah. It's actually on. It's on. Oh. Do we do it today or today? Steal on my team, and I'll play that. Tomorrow I have to I mean, I don't know. No, Giselle, if your interview is not done tomorrow, you'll be sitting and doing that. Alright, so far we got sprinkles. Okay, here, if you step right here, I'll put your name on.
I will buy the entire Walmart if it needs extra credit.
Peanut butter chips now.
I can bring peanut butter, but
Actually, is he allergic to peanut butter?
and peanut butter is
Okay, so like add this one. Okay. That's different than being allergic. I'm allergic. No, very Okay. I'll wait. I'll write this in.
Do I get more money?
I will add it to y'all's lab. Labs are 40% of your grade, which are the same as tests. So it's basically like home money, but adding to the lab.
How much do I get for each thing I bring? Clear out that aisle.
I usually max out like 5. So he rides like a couple.
Did we get the marshmallow?
Yeah, I added that to your. I added that to your quarter. That was first quarter. So I added it to the lab. If it's a lab specifically, I always add it to the lab because they're the same as tests, so in the end.
My mom gave me money to get for the smart lab. Yeah, and it's finally time for me to wear it. It's like a Santa outfit. Look at him. It's so worth it. Already title. Is it the ghetto one that's the one? The new one that's like the same size as that one? The one with the yeah. It's the same as the one, right? It's just that.